Hey, amazing people. We've got another example now where we have a continuous random variable with a probability density function. Now, in this case, it's f of x is defined as 3 over 13 multiplied in brackets of x squared plus 4, close the brackets, and that's for a domain between 0 and 1. Now, we also are told that for all other values of x, so outside of that domain, that the answer is going to be 0 for those points. So we've got that defined domain there, which we have to use. Now, what we're asked to do is we're told to find it correct to 4 decimal places. And we've got a number of different examples here. We've got p of x less than 0.75. For b, we've got p of x, which is less than 0.9. Now, both of these examples are the more common type of one you're going to come across. Now we get to c and d. These ones are actually finding it in a greater part of the graph, but you can still use the probability density function or cumulative density function here to help you calculate these values. So C and D is P of X is greater than 0.25 and P of X greater than 0.65. But again, we can still use this same cumulative distribution function. We just modify what we're doing slightly in order to be able to calculate it. And the last one then is we're asked to find it between 2 points. And this is for P from 0.2 less than X up to less than 0.7. So we've got a range here, which is inside the domain with not the top end or the bottom end of our range acting as our boundaries. And so again, we can take the cumulative distribution function and use it to adjust what we're doing here. But now the first thing we need to do in this question is we need to calculate what the cumulative distribution function is. And so we need to, first of all, find our CDF. Now, as we do this here, we're going to use the same one for all of these questions. And so that's going to be f of x, remember a capital F, and we're going to find it for between 0 and x of 3 over 13 outside of x squared plus 4 dx. Now, as we work through this, again, I'm going to factorize out that fractional part here as we go about this, but I'm also going to integrate it fairly quickly as well. So what we end up with is x to the power 3 over 3 plus 4x. Okay, and we're going to keep our boundary of 0 and x. Now, as I substitute this in, we end up with 3 over 13 bracket, we still have x cubed over 3 plus 4x because we're substituting in this value of x. But when we substitute in this value of 0, we're going to find that actually it's just cancelling out those parts because it's just 0. So there's not actually anything else we need to write here. And so we can just close it off there. And if we want, what we can do just to finish this off and tidy it up a bit, let's expand these brackets out. So we're going to have f of x is equal to, I'm just going to multiply it in. We end up with x cubed plus 12x. And so the 3 underneath the x is cancelled with that 3 there, and then the 3 times 4 is made to 12, and that's all going to be over 13. So this here, this is our CDF, which we're going to be using to find each of these values here now. Okay, now for the first one here, we've got 0.75 as the point we're going to be using here. So all we're going to be doing in this first instance is substituting that in. So what we're effectively finding is f of 0.75, and this is going to be equal to 0.75. That's going to be cubed plus 12 times 0.75. That's all going to be over 13. Now, as we type this into a calculator, what we get is our answer is 0.7248. And again, this is rounded to 4 decimal places as we're asked to do in the question. That's the first one done. Now for the next one, we've got 0.9. So this is going to work in exactly the same way. So we're just substituting that in here. So this is what we're finding. So we're going to have 0.9 cubed plus 12 times 0.9 all over 13. And when we type this into our calculator, the answer we get is 0.8868. And again, this is to 4 decimal places here. So that's the first 2 done. Now for the next 2, because they're greater than, we're doing the upper range of what we're doing here. It adjusts what we're doing just a little bit. Now you might remember that the area of a PDF is always equal to 1. And that's the key thing you just need to remember here. So remember, this is saying that the sum of all probabilities is always 1. And the reason it's 1 is that 1 represents 100%. It's all the possible options here. So that's why the total area under the curve here is 1. Now, what our CDF does, it's doing for just the lower portion here. Now, if we focus on the upper portion, again, when we're dealing with probabilities, to find the opposite, what you often do then is you do 1 minus that probability. So what we're going to do here is we're going to seek to find so P of x greater than 0.25. A way of thinking about this is 1 minus P of x of less than 0.25. And this is what we're going to apply here to be able to find it. And so as we go about this now, what we're going to have then is we're going to have 1 minus, now we're doing less than 0.25. So that's just a matter of typing 0.25 cubed plus 12 times 0.25. And this is going to be all over 13. Okay, and then when we type this into a calculator, we get a response of 0.7680. And this is to 4 decimal places here. All right, next up, similar one again. This time it's up to 0.65. So again, what we're going to do is we're going to rewrite this in another form. We're going to have 0.65. This is going to be equal to 1 minus P of x being less than 0.65. Okay, and as we apply this here, we end up with 1 less than 0.65 all to the power of 3 plus 12 times 0.65 all over 13. And when we type this into our calculators, what we end up with is we end up with 0.3789, and again to 4 decimal places. That's our answer. Now for this last one, it's similar in how it works as well. The way we're going to break it up is we're going to look to use here, since we're finding it between 2 regions, we're going to find out P of x less than 0.7. But then what we're going to do is we're going to subtract P of x less than 0.2. And that's just going to leave the boundary between those 2 points of 0.2 and 0.7. So as we calculate this now, this is going to give us 0.7 cubed plus 12 times 0.7. And then we are going to, sorry, that's all over 13. And then we're going to subtract 0.2 cubed plus 12 times 0.2. Or again, all over 13. When we type this into a calculator and work it out, what we end up with is 0.4873. And again, this is to 4 decimal places. And that's how we can use the CDF to really cut down on the working we have to do and be able to use something which is similar, which we're coming across time and time again. Rather than repeating that same work, we're able to pick it up and use it in a more efficient manner.